Good evening. My name is Tom, and as you've just realised, my job title is very confusing. So I thought I'd start today by just asking everyone to raise their hand and keep it raised if prior to tonight you have heard... No? Where's it? Come on, you can do this. Come on. It's all right. You can keep your hand raised if you've heard of the job human factors engineer before. Okay, we have some. This is good. Fantastic that my director has kept his hand up. That's the main thing. Brilliant. Okay, so my role is human factors engineer here at Renishaw. And as a human factors engineer, my mission is to try and bridge the gap between the end users and the technology that we are designing and manufacturing. And it may seem a bit strange to sort of say that in the sense that, surely everything is designed for the end user. But there's a lot in the design of new sort of technology and new products, which can mean that it's easy to lose focus on the fact that there's not just one person using that product or process at the end, but a huge range of people, all with different capabilities, all with different sort of experience and knowledge. And especially here at Renishaw, we produce products and manufacture around the world. So again, the types of people that we're sort of selling our products to range in these huge capabilities. And when I say capabilities, the type of things I'm talking about are things like sensory capabilities. So your sort of vision, the fact that sort of there's 1 in 12 men, I believe, are colorblind, or things like cognitive capabilities, so sort of memory loss, and definitely as you get sort of the ability to possibly not be able to retain all the information throughout the day. But then you also have sort of physical capabilities, so strength and the ability to sort of, fatigue, all those kind of things. So when designing these products, my role is to constantly sort of remind the design teams about their end users and get them to constantly kind of remind themselves about the way they're designing a product will have a really big impact on who can use it and how easy it is to use that product in the end. So when you think about sort of the design of products and processes and services, I often sort of come across the fact that sometimes it's easy to forget that everything that we kind of come in contact, it has been designed, even though sometimes you may sort of question who they designed it for. And in my sort of career, I've been really fortunate to be involved with a wide range of different industries and different products. So I've worked in the oil and gas industry, sort of designing oil rigs. I've worked with the rail industry, designing trains and signalling centres. I've worked with consumer products, designing leaf blowers. That was a fun job. And I've worked in the pharmaceutical industry, designing injection devices and inhalers. And with some of those, again, it's quite easy to think, well, an injection device, surely you don't necessarily need to worry too much about the end user. The needle needs to be sharp, it needs to be precise. The vial holding the medicine needs to sort of prevent contamination. The mechanisms inside need to ensure a very precise dose. Surely that's just all, someone else's bag. Don't worry about the end user. But with those types of products, my role was to constantly remind them that actually with conditions like diabetes, you have visual impairments and you sort of lose some of your vision. You have nerve damage. Through sort of testing of your blood, you lose the sense of touch on the end of your tips of your fingers. So when I worked with these companies and they were designing pens where you had to carefully dial up the dose and be very sort of precise, we had to keep on re-engaging with them and make them kind of think about the problem differently and think about actually, can their end users see that? Can they actually feel the change? Can they think, and are they going to be really, really scared that they're about to then inject and possibly overdose or underdose with that product. Now, it's no different in manufacturing. Bit of a jump, I know what you're saying. But fundamentally, what I'm saying is, every product can be improved, and every product, as long as you're sort of thinking about the end user, has the ability to get better and be usable by a much wider range of end users. And in manufacturing, in my current role, that's what I'm doing. I'm sort of working with the project teams, and I'm applying the same thing as the same thinking as with that injection device sort of example, to get people thinking about, okay, what's the range of different people that are going to be working in the manufacturing process? What's their capability with regards to lugging big pieces of metal around, or the ability to sort of repetitively assemble a product? In the packaging, we're thinking about the way that we're having to sort of move large quantities of products, all the way up to the disposal, where we're thinking about, when we're taking these things apart, we're trying to recycle. Again, am I thinking about the range of people, where this is going to happen, the environments, the kind of things and materials that they may come in contact with. And we're looking for these constant ways to improve it. And improve it for everyone. So if I think about the most extreme example of someone in our assembly hall, possibly who has lost a limb, can we design the jig that's allowing us here at Renishaw to build our product to allow them to use it? And if the answer is yes, then that means that everyone else will be able to use it as well, but it will be so much more easy to use for everyone. So in summary, the importance of human factors throughout all industries, but focusing here on sort of Renishaw, is that by designing for the widest range of end users, we can minimize the risk of injury, because if it's easy to use, then you're less likely to make a mistake. We can enhance the productivity. Again, if it's easy to use, you're going to be kind of better at it, you're going to be sort of more skilled. We can take away sort of some of the fatigue and the physical strain by thinking again about, okay, do you actually have to lift that? Could you actually use some tools or mechanism to take away the physical strain? We can improve the quality of our products, again, by ensuring that, there's no room for errors, that you're out one with the process, that it's all going smoothly, and also that we can be more inclusive. So by considering the range of end users, we can break down those barriers to who can be actually employed within Renishaw and who we sell our products to, who can use it in other companies as well. So to sort of summarize then, although I do have 2 more slides and a minute to go, we can see that that's all the benefits of considering human factors, is that sort of being more inclusive, being more considerate of who our users are, and by improving the quality and reducing the amount of errors, we're also then sort of tying into that whole sustainability kind of movement and thinking about sort of reducing the waste and the scrappage of our parts. Very quickly, the last 30 seconds, tying into what Mark sort of said right at the start, the future of manufacturing with the sort of inclusion of robots and AI and big data sets, again, is something we're really kind of considering now in human factors. And again, the big thing is, from the other talks, not that we're going to necessarily lose the people in these kind of roles, but actually it's how the people then interact. So again, my job looking forward is going to be looking at how do we actually interact with the robots? How do we interact with AI? How do I ensure that people designing with all these tools and processes are considering of the wide range, the vast kind of differences in how people are going to work with these products? I think I made it. Did I make it? Was that the gun going off? Just, Brilliant. Thank you very much.